Alright, radian measure. The easiest way to think of radian measure is as another unit for circular measurements. For example, right now there's a lot of physical distancing going on. Some people say 6 feet, some people say 2 meters. They both mean roughly the same linear distance. So last year you would have seen a circle would have started at 0 degrees. It increases as you rotate that way. So I've got 0, I've got 90 degrees, I've got 180 degrees, I've got 270 degrees, and then it comes back to 360 degrees. So that's degrees. One complete rotation, 360 degrees. In radians, if you start at 0, there's no degree symbol. One complete rotation from 0 all the way around is 2 pi. How does that come about? Well, let's look at the definition. If you had a circle, let's say that was the angle. By the way, that's also where the angle symbol comes from. We use a variable called theta. So I'm going to put that down here. Looks like a capital O with a line at the top. It's pronounced theta. It's the Greek alphabet. It's the letter used to measure angles. So theta is the variable for angles. So that angle theta is defined as follows. So consider you have a radius for that circle. This arc length A, so that angle is equal to the ratio of the arc length to the radius. You need to remember this formula. Let me show you where the 2 pi comes from. If you took a complete circle, the circumference would be 2 pi times the radius. So if you consider a complete circle of radius r, if we did the complete circumference from start all the way to finish, that would be 2 pi times the radius. And we took the ratio of the arc length, the complete circle, to the radius. What happens is these two cancel out, telling us that the complete circle, regardless of the radius, one complete rotation, one complete revolution is always 2 pi. Now with radians, we don't write any units, we just leave it as the numeric. If you get a number as an exact value with pi, leave it there. And you'll see later on when we do conversions that you can leave it as 2 decimal places. So, 2 things that you want to focus on, and just 2 things, right? Is how do I go from degrees to radians? To go from degrees to radians, you multiply by pi over 180 degrees. We'll see some examples in a few seconds. To go from radians to degrees, our conversion factor is 180 degrees over pi radians. I said two things, but there's just three things. You need to know how to go from degree to radians, you need to know how to go from radians to degrees, and you need to know how to use this formula. The angle subtended by an arc is equal to the length of the arc divided by the radius. So we're trying to convert from degrees to radians here. We have 30 degrees. We'd like to convert that from degrees to radians. So when you do that, the conversion factor is pi over 180 degrees. Notice how you have degrees on the top and bottom, so they cancel. 30 divides into 180 6 times. So this gives us an exact value of pi over 6. That's an exact value. It's as a fraction. Beautiful. The question also says, what's an approximate radian measure to the nearest hundredth? So approximately pi over 6 would be 0.52 radians. So this is your exact value. This is your approximate value. And when you give your approximate value in radians, 2 decimal places is fine. So the next thing we want to do is go from radians to degrees. So our conversion factor is 180 degrees over pi. And so what's going to happen is the pi cancels on the top and the bottom. 4 divides into 180 45 times. This is a special angle, pi over 4. In a few days you should automatically recognize that pi over 4 is 45 degrees. For 5.86, I'm going to multiply by 180 degrees over pi. My calculator is in radian mode. I'm going to type into my calculator 5.86 times 180 divided by pi. And to the nearest tenth, that would be 335.8. degrees. So here's the situation. We've got a carousel. And we've got a camel that's on the carousel. And that camel is 9 meters from the center. The carousel turns through an angle of 5 pi over 6. So what they mean is this whole angle is 5 pi over 6. They want us to find what this distance is that the camel traveled. So theta, the angle subtended, is equal to the arc length divided by the distance from the center. We know the angle is 5 pi over 6. That's given to us in the question. We are looking for the arc length, and we know that the camel is 9 meters from the center. So that gives us a nice linear equation for us to solve. So in order to solve for a, I just have to multiply this side by 9. So that's going to give me a on the right side is equal to 9 times 5 pi over 6. And they ask us for the length of the arc to the nearest tenth of a meter. So when I do 9 times 5 pi over 6, I get A equals 23.6. So the length of the arc is 23.6 meters. Alright, now example 4, they're talking about the angular velocity of a rotating object. They tell us the hard disk platter is rotating at 7,200 revolutions per minute, and they want the angular velocity in degrees per second. So what we are trying to do is take 7,200 revolutions per minute and convert it to degrees per second. Now, here's the thing. For every 1 minute, there are 60 seconds. So now I've got my seconds in the denominator, and I need degrees on the top. So I know that every complete revolution, so one complete rotation around that circle is 360 degrees. So what's happening here? The units are all cancelling out. Watch, minutes and minutes cancels. Revolution and revolution cancels. And so now you have degrees per second. Alright, 60 divides into 60 once, divides into 360 6 times. So when I multiply all of that out, my angular velocity is 43,200 degrees per second. So let's try the same thing in radians per second. I've got 7,200 revolutions per minute. I know that every minute has 60 seconds, and every revolution has every revolution has 2 pi radians per 1 revolution. So my revolutions and my revolutions cancel out. Minutes and minutes cancels out. Now I've got 7,200 times 2 pi divided by 60. 60 divides into 60 once, and it divides into 7,200 120 times. So that gives us 240 pi radians per second.